Chapter 9 Summary. Network segmentation. Reasons for subnetting. Subnetting is the process of segmenting a network into multiple smaller network spaces called subnetworks or subnets. Large network must be segmented into smaller subnetworks, creating smaller groups of devices and services to control traffic by containing broadcast traffic within each subnetwork, reduce overall network traffic, and improves network performance. Communication between subnets. A router is necessary for devices on different networks and subnets to communicate. Each router interface must have an IPv4 host address that belongs to the network or subnet that the router interface is connected. Devices on a network and subnet use the router interface attached to their LAN as their default gateway. Subnetting based on the host requirements. 2 considerations when planning subnets: number of subnets required, number of host address required. Formula to determine number of usable hosts. Subnetting to meet network requirements. Balance the required numbers of subnet and hosts for the largest subnet. Design the addressing scheme to accommodate the maximum of number of hosts for each subnet. Allow for growth in each subnet, as shown in this figure. Traditional subnetting based addresses. Traditional subnetting, it uses the same number of addresses is allocated for each subnet. Subnet that requires superior address have unused or wasted addresses. For example, one NICs only need 2 addresses, as shown in this figure. The traditional subnetting for its equal size subnets. Variable length subnet mask or VLSM. The variable length subnet mask or VLSM or subnetting a subnet provides more efficient use of addresses. VLSM allows a network space to be divided in unequal parts. Subnet mask varies depending on how many bits have been borrowed for a particular subnet. Network is first subnetted and then the subnets are resubnetted. This figure shows the subnet of varying sizes. One subnet was further divided to create 8 smaller subnets of 2 hosts each. VLSM in practice. Using VLSM, subnets the LAN and WAN segments. In example, below NV address with minimum ways. Each LANs will be assigned a subnet with /27 masks. Each one link will be assigned a subnet with /23/30 masks. As shown in this picture, the network topology of VLSM subnets. Planning to address the network. Allocation of network addresses should be planned and documented for the purpose of preventing duplication of addresses, providing and controlling access, monitoring security and performance. Client addresses usually dynamically assigned using the Dynamic Host Configuration Protocol or DHCP. This is a sample network regression plan as shown in this video. The summary. In this chapter, we learned that subnetting is the process of segmenting a network by dividing it into multiple smaller network spaces. Subnetting a subnet or using BLSN was designed to avoid wasting addresses. IPv6 address space is subnetted to support the hierarchical design of the network. Size, location, use, and access requirements are all considerations in the address planning process. IP network must be tested to verify connectivity and operational performance. In addition, the transport layer provides transport-related services by dividing data received from an application into segments, adding a header to identify and manage each segment, using the header information to reassemble the segment back into application data, and passing the assembled data to the correct application. UDP and TCP are common transport layer protocols. UDP datagrams and TCP segments have headers added in the front of the data that include a source port number and destination port number. These port numbers enables data to be directed to the correct application running on the destination computer. TCP does not pass any data to the network until it knows that the destination is ready to receive it. TCP then manages the flow of the data and resends any data segments that are not acknowledged as being received at the destination. TCP uses mechanism of handshaking, timers, acknowledgement messages, and dynamic windowing to achieve reliability. The reliability process, however, imposes overhead on the network in terms of much larger segment headers and more network traffic between the source and destination. In the application, data needs to be delivered across the network quickly, or if network bandwidth cannot support the overhead of control messages being exchanged between the source and the destination system, UDP would be the developer's preferred transport layer protocols. UDP provides none of the TCP reliability features. However, this does not necessarily mean that the communication itself is unreliable. There may be mechanism in the application layer protocols and services that provides lost or delayed data graphs if the application has these requirements. The application developers decides the transport layer protocols that best meets the requirements for the application. It is important to remember that the other layers all play a part in data network communications and influences its performance.